statistical model? Or can we, is there a way we can think about, we can apply mathematical precision to making certain predictions? Who's likely to get COVID in this population? Who's likely to get a vaccine in this population? Are there things that we know about this population that can help us to predict and even quantify how accurate our prediction is likely to be? And the third thing, which is what we do most often and that we find in most of the papers that you would look like, is, kind of understand what is the nature between certain exposures and outcomes. What is the effect of smoking on death outcomes? Those are the three main things that we do with statistical analysis, and how we do the analysis, the kind of methods, the kind of theories that are applicable kind of differ. But at the core of it is that irrespective of method, there are certain assumptions that are made that make the methods valid, and those assumptions rely on our understanding of basic concepts about what is the nature of our data, what is the nature of the variable in the data, what is the nature of the measure that we are trying to understand. Is it a ratio? Is it a proportion? Is it a rate? What is the nature of the variable that makes up these measures? Are these nominal? Are these ordinal? Are these continuous variables? And that's why it's important for us to understand all the things we've talked about earlier. So now I'm going to move a little bit faster because I think we can move on. Next slide. Next slide. So now, I mean, most of what we're going to be talking about now is going to be a lot of revision. So it's going to be a little bit faster, but it's getting too fast. Still, you can call my attention to that. So if I ask the question, on the average, what is the height of guys in Lagos? Or are guys in Lagos taller than the guys in Nairobi? What would be your response? So I'm sure that if we have about over 500 people on this conversation, you are likely to get so many impressions. But here's the thing. If you look at the impressions that people form so much, you will find out that when you ask people, how tall is the average guy in Lagos? People are thinking about it in a variety of ways, but there are three common ways in which people think about it. There are people who, when they answer, they would say, well, it looks like guys in Lagos are kind of short. If you ask them what they mean is that, most of the guys that you encounter in Lagos are kind of on the short side. So I think that guys in Lagos are shorter than guys in Nairobi. For some others, you would hear them say, there's a lot of short guys in Lagos, but I think that altogether, I would say Lagos is taller than Nairobi. Why? Because there's a lot of short guys, but also there's a lot of very tall guys. So when you take them together, it looks like Lagos is kind of, it's kind of taller. The point I'm making is that when we ask people about what is the typical case, what is the typical case of a particular phenomenon, what is the typical height of guys, what is the typical birth weight in a place, what is the typical wealth of an individual in a place, the way we think about it kind of different. And the question we're asking when we say what is the typical, that exactly is what we call the central tendency. Now, so I'm going to talk about three ways in which we do. The first one is the arithmetic mean, which I think most of us are very familiar with. And what that arithmetic mean does is that it basically just adds together all the measures, all the values, and divides it by the number of values. So in this case, somebody wouldn't say, well, because there are 3 short guys and there are 5 8 guys here, what we need to do is to measure the actual heights, add it together, then divide it by 8. That's how we will know how many guys. That's how we know what the average height is here. So the other measure, one drawback that you have with the mean though, is that when there is an outlier is someone who's so different from the rest of them, the mean can give you a figure that doesn't so much as make a lot of sense. And here's the thing. So for instance, if we're saying Okay, let's see, among two groups, let's see which of the two groups is wealthier. So you find a group that has 10, 15 people, you have another group that has 15 people, and you're trying to figure out who's wealthier. And you say, okay, let's calculate the average wealth in group A and the average wealth in group B. If it turns out that in group A, one of the people there is Dangote, and the rest of the people are, medical students from my alma mater. If you calculate the wealth of everybody in that group, add it together and divide it by 10, the figure it gives you is the arithmetic mean. Yes, it tells you some kind of average, but is that what most people are thinking about when they're asking you what is the typical wealth in that group? It is not. It is not. If you base a policy on say, oh, looks like this group is very rich, we don't actually need to provide any welfare for this group, it turns out you would end up making very wrong policy for that group. In essence, because Dangote in that group is an outlier, it kind of shifts what the arithmetic mean in that group would be much higher and gives a false impression of the situation of all the other people in the group. Now, the other kind of measure that we use here is the median. Essentially, the median is just like say, okay, let's not bother adding everybody together. The person who's typical would give us what the typical value here is. Out of these 10 people, out of these 11 people, look at the person whose wealth is in the 6th position and let that be taken as a typical wealth level for this group. Now, the advantage of that is that, in a class of people where you have somebody who's so rich, that person's wealth would not tilt the median because it doesn't change what the wealth level of the 6th person in this group would be. So when you have skewed data, which means that there are outliers, there are people who are so different from the group, the median tends to give you a more typical value, a value that is more representative of the group. Next slide. And the last one is, next slide. So yeah, I already made this point. The median is robust to outliers, meaning that outliers would not change the median a lot. But if you calculate the arithmetic mean in a group where there is an outlier that's far ahead, you can get a wrong impression of what that group represents. Let's move on. So the last measure I want to talk about, there's a slide here. Before we go to that poll, the last measure I want to talk about is the mode. And the mode basically means that the value that occurs most, the mode occurs most. And so that's like saying that, in this group of 15 people, for us to know what the average, if you ask me what's the typical wealth here, just look at all the 15 of them, ask them for the amount of wealth, and the value that you have, most people having, is what is the typical value. There are situations where that can be helpful, but it depends on the question we're asking. Actually, which of these 3 measures of central tendency would be most useful would depend on the kind of question you're asking ultimately. But one thing you should take away from this is that when somebody says, the average wealth or the average height or the average, you need to probe further and try to figure out, when you say the average, what kind of average are you thinking about? Are you thinking about the mean? Are you thinking about the median? Or are you thinking about the value that occurs most? And sometimes in a population, and the reason, one of the reasons why we have to be careful about mode is that sometimes the mode, populations can be multimodal or sometimes bimodal. For instance, there are diseases, there are conditions where people much early in life are susceptible, but also people much later in life are also very susceptible. So that kind of condition is bimodal, but just merely looking at the distribution would not tell you that, looking at other measures. So you look at the arithmetic mean, you look at the median, would not tell you that what's happening here is that there's a clustering at two extremes. Let's move on. So here's poll 2. Can you bring up the poll for?
Okay, bring it up.
Okay. So you recorded the heights of the kids attended to at the pediatric outpatient clinic each day this week. First, you plot the histogram for day one. If your histogram indicates the data may be normally distributed, which average would you use? I think I'm just going to give 60 seconds for this one.
So perhaps when we close the poll and we finish discussion the poll, we can take 2 questions that, yeah.
Okay. So I think we've had enough time for the poll actually.
Okay.
Okay. So I see a lot of means here, 75, a lot of median. Okay. So can I have someone from, okay, Mohammed, I see that you took B. Okay, so Juliet, I see that you took B, which is the median. Do you want to tell us why you think B should be the answer here?
So it's Sue Juliet in the class. Which one? Juliet Shaibu?
No, Juliet Obedi, I think.
Okay, all right.
Juliet, do you want to tell us why you think that the median is the right one here? Yeah. So while Juliet is getting ready, is there someone who wants to tell?
Yeah,
go ahead.
I chose the median because the data is, I mean, if you check at the, sorry, excuse me once.
So while Juliet is getting ready, can we have someone who chose Maine who wants to tell us why? Ibrahim Riba, do you want to tell us what you think, which one you think is correct? Okay, I need a volunteer to tell us why they think either the mean or the median is correct, apart from Ibrahim and Juliet.
So, Temitayo.
All right, thank you very much. I would go for the mean because the question says that the data is normally distributed. And I think that from the previous slide, we're made to understand that if it's a normal distribution, the mean is more accurate. That's my response.
Okay. So who else wants to make a comment on that? Well, essentially, yes. I just tell people generally that, the mean, when most people talk about average, they're actually talking about the mean. The mean tends to represent the data much better. It is when your data is not uniformly distributed, meaning that when it is skewed, meaning that when you have outliers, that is when you need to think about looking for another way to deal with this data. And that's usually when the median comes in. When you have an outlier, remember the Dangote example in the class that I gave you the other time. When you have those kind of outliers, that is when we say that the data is skewed. That is when we say that the data is not normally distributed. And that's when you need to, that's when a median is likely to be better than the mean.